Hello students, welcome to this class. An interesting topic, how an aircraft produces lift. Before going to this topic, we should know the terminology called pressure, which is very important.
Now we should go to this topic. See this picture. You are very much familiar about this machine. Whenever you are going to hospital, the doctor first will check your body is at normal level or not. So pressure measurement is very important. See these figures. Consider this is first case and this is second case. Here you have a hammer and a nail. Here also you have a hammer and a nail. Both are same thing, but the nail having contact with the wall is different in both the cases. In first case, the sharp edge is making contact with the wall, and in the second case, the head of nail is making contact with the wall. The amount of force being applied is same in the two cases. The amount of force is being applied by the hammer. In the first case, nail will penetrate, but in the second case, it will not penetrate. Due to force, the amount of pressure created in which case is higher, in which case is lower. In the first case, the contact area on the wall is very less when compared to the second one. This can be identified by the mathematical expression shown in here. For high pressure application, vegetables are sliced by means of a knife. The soft edge is used to cut the vegetables in both the figures. The amount of pressure created is relatively more when compared to the other end, which is relatively blunt. Here another practical application, a tree is being cut by using axe. The axe which is going to be in contact with the tree, which is small. So more amount of pressure is created. Another practical application, a syringe needle. In syringe needle, the pressure created while applying force by the syringe needle making contact with the body is lesser, so more amount of pressure is created during this exercise. This is an aircraft having two wings. The cross section of the wing is called airfoil. Here you have a top surface as well as a bottom surface. At the top surface, the air needs to be travelled more distance than the bottom surface. The pressure on the top surface is lower, at the bottom surface is higher. Due to the pressure difference between the bottom and the top surfaces, the wings will be lifted up. This is called Bernoulli's principle, and thus the lift is created on the aircraft wing. I hope you all understand how an aircraft produces lift through the pressure concept. What are the types of stress? Already we have discussed about stress. The stress is nothing but the internal resistance offered by the body to meet with the load, as well as the unit of the stress is Newton per meter squared. And what are the different types of stress? One is tensile stress. The stress is induced by the nature of load called tensile load, which is called stretching or pulling load. In this load, we are applying a load on this material. The stretch will be there, so that the elongation will be occurring. So due to the load, the stress produced in the material is called tensile stress. Generally, the tensile stress is considered to be positive stress. Next type of stress is called compressive stress. Here the nature of load is compressive in nature. So we have to apply a load on the material by means of applying compressive load. The elongation will not be there. Instead, the reduced in length will happen. Due to the reduced in length, lateral dimension will increase. So when applying this compressive load, what is the stress is produced on the material is called a compressive stress, as well as the compressive stress always being considered as a negative stress while mathematical applications. And we are going to discuss about the strain. Strain is the change in dimension to the original dimension. Generally, we have two types of stress, two types of strain called linear strain as well as lateral strain generally. Okay, and I already discussed about the strain. But what are the different types of stress as well as what are the different types of strain is the matter here. One is called a tensile strain, another one is called a compressive strain. So whenever the load is applied on the material gets strained. If the load is tensile, then that strain produced is called a tensile strain, as well as the nature of load is compressive load. The strain produced on the material is called a compressive strain. Next, we are going to discuss about the important topic called stress strain diagram. Here, a material is going to be tested on UTM, that is called a universal testing machine. Now we are going to apply the tensile load. So it can withstand up to how much load. We are going to test at what load the material will go to failure mode. We are going to discuss some of the quiz related to Hooke's law. First, we already discussed what is Hooke's law. It is the stress is directly proportional to strain within the elastic limit. That is the statement already discussed regarding Hooke's law. Now let's move on to some of the quizzes related to Hooke's law. First quiz is that the ratio of ultimate stress to the permissible stress. That is what? The options given are a factor of safety, safety ratio, safety measure, none of these. And the answer is factor of safety. Factor of safety is the ratio between the ultimate stress to the permissible stress. The second quiz is, which of the following is an application of Hooke's law? First one is, it is used in all branches of science and engineering. The second option is, it is the fundamental principle behind a manometer balance wheel. The third one, it is the foundation for molecular mechanics, acoustics. And the last one is all of the above. So Hooke's law is applicable to all the above. That means it is used in all branches of science and engineering, fundamental principle behind manometer balance wheel, and foundation for molecular mechanics, acoustics. So all are the applications of Hooke's law. The third quiz, which of the following is the disadvantage of Hooke's law? Options are, first option is, it is not a universal principle. Beyond the elastic limit of the material, the law is not applicable. The third one is, it is applicable only for solids. The third one is all of these. So Hooke's law is not a universal principle, and beyond the elastic limit it will not be applicable, and it is applicable only for solids. All are correct. So all of these is the answer. And fourth quiz is, the strain of the material is proportional to the applied stress within the elastic limit of that material. The options are stress law, Hooke's law, Poisson's law, Bernoulli's law. So here I already told that Hooke's law is stress is directly proportional to strain within the elastic limit of the material. The same thing is given in terms of strain. The strain of the material is proportional to the applied stress within the elastic limit of the material. It is also Hooke's law. The answer is option B, Hooke's law. Fifth one, which of the following is an example for non-Hookean material, non-Hooke's law? Okay, so that is called as non-Hookean material. Copper, aluminum, rubber, steel are the options. So copper, aluminum, steel, so all are going to elastic range and plastic range, everything. But rubber rubber, so you will not have any elastic material. That is, even it is an elastic material, that Hooke's law will not be applicable for the rubber. So the option is rubber is a non-Hookean material. Finally, last one thing is to be discussed. What is the change in length due to the axial load applied on the material? Actually, it is derived from the Hooke's law only. So here already given that the stress is directly proportional to strain, and we are introducing a elastic constant Young's modulus. So stress is defined by load by area, and strain is change in length by the original length, and Young's modulus as it is. From this we can have a del, factual detail. So from that we can have an equation PL by AE, here EA, so no problem, PL by AE, where P is the applied load, L is the length, A is the cross sectional area, E is the Young's modulus. So the unit, when applying this mathematical expression, unit must be followed like if load is in terms of Newton and the length is in terms of meter, then the Young's modulus must be Newton per meter square and area must be meter square. If it is applied, load is applied in terms of kilonewton and length is millimeter, then you can use Young's modulus as kilonewton per millimeter square and area as millimeter square. So accordingly the unit must be followed while mathematical applications, so that we can get the correct answer, otherwise we will have a error. So that's all from this class. We will discuss later. Thank you.